So previously we talked about derivatives, right? And its applications. So we've learned about so many applications of the derivatives, right? So the calculus one is about not only derivatives, it's about the applications of the derivatives. So what we've learned about the applications, we've learned how to approximately find the roots of the functions, right? Like a Newton's iteration, when we need to make a lot of tangent lines in order to approximately find the roots. Or we've learned about how to find the maximums and the minimums, right? Yes? You're looking so surprised. So how to find the maximum and minimum of the functions? So if we're given a function, f of x, and if I would like to find its maximum or minimum, we need to, maximum or minimum, we need to take its derivative, right? Equalizes 0 and find the critical points, right? So once the critical points are known, how do I know whether what is the maximum and what is the minimum? Yes? Yeah, so what we can do is we can substitute. So let's see. So first step, we take the derivative, right? Second step, we found all the critical points. Now we need to figure out what is the maximum and what is the minimum, right? So he suggests to put the values into the function and define which is the bigger, which gives you a bigger result for f of x and which gives you a smaller result for the f of x, right? But sometimes if your function is too difficult, for example, if your function is like 350 minus x 1 over 2, 200 minus x or something like this, then putting there the values, for example, if I ask you, hey, the critical point is x is equal to the 455.6, then putting this and calculating the value of the f it takes a lot of time, right? Is it possible to figure out the maximum or minimum without calculating its value? So let's say in the question I'm asking you, I'm not asking you what is the maximum value of the function. I'm asking you what is the point where the function attains its maximum or minimum. Okay? You found two critical points. Now you need to tell me which one is the maximum point, which one is the minimum point. Do you understand this? Yes? Do you understand what I'm talking about? Yeah? Okay. So he suggests me, so just put two values to the function, evaluate this, right? The biggest will be maximum, the smallest will be minimum, right? We can do this differently. What we can do is we can put the critical points on the interval, right? For example, if the critical point is x1, the first one, the second one is x2, right? And if I've got plus, minus, plus signs, for example, right? It means that the function is increasing until x1, decreasing until x2, then starts increasing, right? It means that x1 is the maximum point, right? Because it increases until x1, then starts to decrease, right? It means that x1 is the maximum, or local maximum, we call this like this. So x2 is the minimum, because before x2, the function was decreasing, right? And after x2, it goes up. So that is why x2 is the minimum, right? We can figure out what is the maximum and what is the minimum points without evaluating the function at those points. Okay? Or another method is to find the second derivative of the function, right? And find the zeros of the function. So find the increasing and decreasing regions, right? Do you understand why we need this increasing and decreasing regions? Do you conceptually understand this? If no, like you need to ask, right? So the function, I don't know what is the graph of the function, right? But it should be something like this. So until x1, it should increase, right? Until x1, it should increase. Then after x1, it should decrease. And after x2, it should also increase, right? So that is why this point is the local maximum, and this point is local minimum, right? Do you understand this? So we can know this without evaluating what is the height of the function, what is the height of this red curve, right? By just knowing the increasing and decreasing regions. So another possibility to find whether the point is the maximum or the minimum, we can find the concavity regions, right? Concavity. Find the concavity regions. So in this case, we need to find the second derivative of the function, equalize the 0, and find the roots, right? Roots means that find the x values so that the ft prime at those values will be equal to the 0, okay? Then we will do again the points. For example, let me call them as x3 and x4, okay? Then I will put here the signs. For example, plus, minus, plus, right? So what does it mean, this plus now? So it doesn't mean anymore increasing region, right? Now it means that concavity region. So until x3, the function is concave up, right? It looks like this. After x3, the function is concave down, right? And after x4, it's again the concave up, right? So it should look like this. So let me try to draw this. x3, x4. For example, your function is concave up until x3, right? For example, like this. Then after x3, it's concave down, right? Then after x4, it's again concave up, like this. For example, right? I mean, this might be different as well. Do you understand the concavity, right? So we say that if you find the x1, for example, you put the x1 now here onto the second interval. For example, if x1 is here, okay, somewhere there, it means that x1 is the maximum point, right? Why I can put the x1 here and know whether it is the maximum? Why? No, because it means that at this region before x3, between x3 and x4, the function is concave down, right? What does it mean, concave down? It looks like this, right? All the tangent lines are above, right? If it looks like this, and if your extremum point there, somewhere here, right, it means that this is the highest point, right? So that is why if the second derivative is negative, then if your extremum point is in the region when your function is concave down, then it means that x1 is the maximum, okay? Because it looks like this. Do you understand this? Yes? So where I need to put x2, I need to put x3, for example, here, right? So if x2 is again the extremum point, what does it mean? It means that the horizontal line, the tangent line is horizontal there, right? So if in this region your function is concave up, right, it means that at those points you attain the minimum, right? You understand this? If your function is concave up in some region and your extremum point is there in that region, it means that at that point your function attains its maximum, okay? If it is concave down. If it is concave up, in that region, your function attains its minimum, okay? So that is why. What you need to do, so once you found the critical points, you can know the maximum or minimum. First, by finding the increasing and decreasing regions, okay? Second is by finding the concavity and by defining where your extremum points are lying, whether they are lying in the region where the function is concave up, whether they are lying in the regions where the function is concave down, okay? So in the online quiz, there are questions on this. So you need to do the problems with both methods, and you need to compare them, okay? Should we do an example? No, sometimes you might get like a plus, 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 for example. Yes, so depending on your function. For example, sometimes it might be minus, minus, plus, or minus, plus, plus. Huh? Yeah. For example, if it is quadratic, for example, if your function is f of x, f prime of x, right, is equal to the x minus t in the square, it means that ft prime of x is always positive, right? Even though it has the extremum point at the point 2, right, it is always positive. no matter what you put for the x, right? So you will draw the interval like this. You will put the t here. After the t, it is plus, and before the t, it's also plus. Okay? Sometimes, if you're, for example, if the f prime of x is equal to the t minus x, then the root is at the 2, but for the x's bigger than t, it will be negative. For the x's below the t, it will be positive. Okay, so sometimes it might be minus and plus. Okay, so the best way in order to know what is the plus and what is the minus is to just take one number from each of the regions, put this to your function, and check the sign. Okay, so take any number from here, for example, 3, right? Put this to this function, it becomes minus 1, right? So that is why for all the numbers more than 2, it is minus. Take one number from here, for example, 1, right? Put it here, this will be 2 minus 1, 1, right? So for all the numbers below the 2, your function, f prime of x, will be positive, okay? So if you don't know whether this is plus or minus, just take the number, choose any number in this region, so that you can evaluate this function very quickly, and check the sign, okay? So if you've got plus, it means that in the whole of this region, your function will be plus. The sign of the function will be plus, okay? You understand this? Okay. I don't know what kind of example we can make. Why, if it is plus, it's concave up? Okay. Okay, we'll do an example. Or I can explain it like this, okay? So concavity, one more time. So by the way, you can watch this on YouTube. We've learned this. We've got a lecture. Let's say, do you remember why we say that so when the function is increasing, for example, like this, okay? Or let me put it like this. The function is increasing, right? So I would like to see the slopes of the derivatives, right? So the slope of the tangent line, sorry. So the slope of the tangent line is here. It's some m, right? Do you remember we discussed this? If you look to your notebook, right? If you can put your left hand in order to draw this tangent line, then it means that the slope is positive, right? If you put your right hand, then your slope is negative, right? Do you remember? So the slope, if your tangent line is like this, then the slope is equal to the 0, right? If it goes like this, it will be positive, okay? If you put the right hand, then this will be negative, okay? If you put the vertical, this will be infinity, okay? Do you understand this? So now here, the slope is positive, right? For all the points, here, for example, or here, right? The slopes are always positive. Do you see this? The slopes are positive, right? It means that what is the slope? So the slope of the tangent line at every point, it is simply derivative of this function, the value of its derivative, right? So the value of the derivative of the function is positive for all of these points, right? So do you remember how we link the increasing regions with the derivatives, right? We say that since I see from the graph that the slope of the tangent lines are positive for increasing regions, then it means the derivative of the function is positive. Okay? Do you understand this? Yes? Okay. So f of x is given like this, right? Like a curve. So what we call as increasing? Increasing means that if I choose 2 points, in the second point, the value of the f should be higher, right? Then I drew an example of the function. Then I figure out the tangent lines in many points, right? And for all of these points, the tangent lines are always positive, right? And I know that if I take the derivative of this function and evaluate the derivative of this function at many points and those points, it will give me the slope of these lines, right? It means that in this region, for example, the derivative, the first derivative of the function is positive, right? Do you understand this? So that is why. If the sign of the derivative is plus, then function is increasing. If the sign of the derivative is minus, then function is decreasing, right? Then we came up with the idea of the concavity, right? We'll say that I would like to figure out what is the concave up or concave down. So how to identify whether the function is concave up or concave down, right? For example, we drew the function like this. So is it concave up or down? Concave down, right? Then I look to the slope, okay? So this is the first slope, right? This is the second slope. This is the third slope, right? Do you see the slope was like kind of vertical in the beginning, right? Then it becomes more horizontal, right? We say that if the slope is vertical, then it is equal to, the slope is equal to, if the line is vertical, then the slope is equal to infinity, okay? If the slope is horizontal, the slope is equal to 0. If it goes down like this, then it becomes negative, okay? So do you see that the slope of the function is decreasing, right? Do you remember? So in the beginning, it was like almost vertical. Now it becomes like a more horizontal, right? So the slope of the function is decreasing. If your function is concave down, it means that the slope of the tangent lines are decreasing, right? So how we can link the decreasing regions with the derivatives? The derivative of the slopes should be negative, right? Do you understand this? One more time. So I see that in the region where the function is concave down, our observations. So if we find many slopes, the slopes are decreasing. At the same time, we know that the slope of the tangent lines is the first derivative of the function, right? So if I find the first derivative, and if I put the points to this function, to the f prime of x, it gives me the slopes, right? I know that this function is decreasing, right? So the slopes are decreasing. It means that this function is decreasing function, right? So this function is decreasing function means that its derivative is negative, right? So f prime of x is decreasing means that its derivative is negative, right? We just learned about this. So if the function's derivative is positive, then the function is increasing. If the function's derivative is negative, then function is decreasing, right? I know that the slopes, do you see this? The slopes are decreasing. It means that f prime of x, which gives me all of the slopes, is decreasing function, right? Here in this region. Then its derivative should be equal, I don't know what is this, its derivative should be less than 0. So it means that second derivative of the function is negative in the regions where the function is concave down, okay? So that is why when I put the signs here, if the second derivative is negative, it means that the function is concave down there. If the function is concave down there, it means that so at some point it might reach your maximum, right? So if your function is concave up, it cannot reach its maximum, right? It looks like this. So it cannot reach the maximum. It reaches the minimum, right? Oh, what? No, xt. x1 is in the downward, so that is why it reaches its maximum. Here, x3? Ah, okay. Okay. Vice versa. The function, the graph is wrong, okay? Okay. Do you remember we did a lot of optimization problems last time? So let's do one more optimization problem. Optimization. Yes. Can we do what? First option was the difficult. Second option. Let's do, so do not tell me to do the first question because like finding the roots is like, it's ugly there. Second option, right? So 4x cubed plus 3x squared minus 6x plus 1, right? So we need to find the intervals where the function is increasing and decreasing, find the local maximum and minimum, and find the intervals of the concavity, and find the inflection points, okay? So f of x is given like this, okay? So in order to find the maximum or minimum, first of all, we're not talking about, so do you remember what is the difference between absolute maximum and local maximum? So local maximum doesn't mean that the function gets the highest value there, right? Maybe it gets the highest value. We don't know in terms of local maximum. Local maximum is when your function is increasing before that point and decreasing after this, okay? All of these points we call as the local maximums, okay? Maybe this is not the highest point, okay? So the highest point ever for your function is called the absolute maximum. The points where your function is increasing then and decreasing, this points, the point is called the local maximum, right? So it's about the mountains, for example, right? So for example, if you would like to go to the mountains, you need to pass through a lot of local maximums, right? So where you need to go up and down, where you need to go up and down, right? But usually you need to go to the highest point, right? So you need to go to the highest point. This will be the absolute maximum, the highest one. So in the row, when you need to go up and down, those points are the local maximums, okay? Yes, yes. I'm saying you like the absolute maximum can be a local maximum as well, okay? Yes. So I'm saying you. So the local maximum might not be the highest point. Okay, it may be the highest point, it might not be the highest point, okay? So all the points where your function is going up and down are called the local maximums, okay? The point where the function gets its highest value is called the absolute maximum, okay? So in this problem, I ask you to find the local maximums and local minimums because you're not given the interval, right, for the x, okay? So first of all, in order to find the maximum or minimum points, we need to figure out the critical points. So the critical points is when your function's derivative is equal to the 0 or where your function's derivative do not exist, right? So f prime of x, it is equal to the 12x squared plus 6x minus 6, right? We need to equalize this to the 0, okay? So f prime of x is equal to the 2x squared plus x minus 1. It is equal to the 0. Then, do you remember the roots? Okay, x is equal to the minus 1. So x plus 1 over 2 and x like this. Okay, 1 over 2 and 1 is 1, okay? Or you can write this as, what about 2? Yeah, I mean it's, or it is equivalent to the tx minus 1 multiplied to the x plus 1, right? So if you open the brackets, what you will have? Like 2x squared plus 2x minus x minus 1, right? Exactly. So we can write this as 2x minus 1 multiplied to the x plus 1 and equalizes to the 0, okay? So the points minus 1 and 1 over 2 are the extremum points, right? Or the critical points. The critical points are x1 is equal to the minus 1, x2 is equal to the 1 over 2, right? We found them by finding the roots of the derivative of the function, right? What do you have a problem? Option 2. Option 2. Okay, now we need to define the signs. Okay, I would like to know whether the sign here is plus or minus. How do I know? So I need to choose one number, for example, 1. And I need to evaluate this function's value at the x is equal to the 1. If you put 1, what you will get? 2 minus 1 multiplied to the 1 plus 1, it is positive, right? So that is why here I've got the plus, okay? Then, since your function is in the standard form, you will get minus here and plus here, okay? Now you need to write, okay? So increasing regions are from minus infinity to the minus 1 and from 1 over 2 until infinity, okay? So the derivative of the function is positive there, so that is why your function is increasing there, okay? Decreasing region is from minus 1 until 1 over 2, okay? So where the derivative is negative. Now, what? So in the second question, we needed to find the local maximum and local minimum, right? So we don't know what is the local maximum or local minimum, but we know that at the point minus 1, the function attains its local maximum, right? So the local maximum should be f of minus 1, right? Do you remember what was the f? It was 4x cubed plus 3x squared minus 6x plus 1, right? So at the point minus 1, your function attains its maximum, right? Your function is increasing until the minus 1, and after the minus 1, it's decreasing, right? So the function's maximum is f of minus 1, not minus 1, right? So f of minus 1 will be equal to minus 4, right? Plus 3 plus 6 plus 1, right? I've substituted x with the minus 1. You understand this? So this will be equal to the 6, okay? The function's local maximum is equal to the 6, okay? What is its local minimum? We don't know yet, right? But we know that it attains its local minimum at the point 1 over 2. Why? Because before 1 over 2, it decreases, right? Then after the 1 over 2, it starts to increase, right? It decreases, then starts to increase, right? So that is why at the 1 over 2, the function attains its local minimum. So this will be 4 multiplied to the 1 over 8, plus 3 multiplied to the 1 over 4, minus 6 multiplied to the 1 over 2, plus 1, right? So this will be equal to the 1 over 2, plus 3 over 4, minus 3, plus 1, right? If I give the common denominator, it will be 2 plus 3 minus 12 plus 1 divided to the 4, plus 4, sorry, right? I gave the common denominator 4 for all the terms. 2 to the first term, 4 and 4 for the last two terms, okay? So this will be equal to minus 3 over 4, okay? The function's local minimum is equal to the minus 3 over 4. So you need to be careful with the questions which I'm asking you in exam, okay? If I ask you, hey, give me the point or points where your function attains its local minimum, you need to tell me x is equal to the 1 over 2, okay? If I ask you, tell me what is the function's local minimum, you need to tell me minus 3 over 4, okay? Do you understand what is the difference in the questions, right? So if I say, hey, tell me the local maximum of this function, you need to tell me 6. If I ask you, tell me the point where your function attains its maximum, you need to tell me minus 1. Minus 1, okay? Now, we found out the increasing, decreasing regions. We found the local maximum, local minimum. Now we need to find out the concavity regions, right? So it is necessary to take the second derivative of the function. Do you remember what was the first derivative? It was tx plus x minus 1. What? Oh, it doesn't matter, actually. We will divide them anyway to the end, right? So 2x squared plus x minus 1. Okay? Let's take the derivative from this. So derivative will be 4x plus 1, right? So I will need to equalize this to the 0, and I need to find its roots. So what is a root here? Root is equal to the minus 1 over 4. Why? Because if I substitute minus 1 over 4 to the x, it gives me 0 for the second derivative, right? Now I will put the region minus 1 over 4, okay? And I need to figure out again the signs, right? So how to define the sign? So you need to choose any number from here. What kind of number I can choose? For example, 0, right? If you put 0, this is 1, which is positive number. So that is why this region will be plus, and this region will be minus, okay? So this region is plus, this region is minus, okay? Now, what I can do is I can put here the critical points, okay? To the same interval, I can put the critical points. What were the critical points? They were minus 1, yes, minus 1 is here, and 1 over 2, right? So do you remember, if your function's second derivative is negative at this point, it means that the function reaches its maximum, local maximum, right? You understand this? So if the second derivative of your function is positive at the point, at some critical point, it means that your function reaches its minimum, okay? You can either figure out the local maximum and local minimums by figuring out the increasing and decreasing regions, okay? Either by finding the second derivative and putting the critical points here, okay? If you now put the critical points, you can see where the function is concave down and concave up, okay? If the function is concave up at some critical points, it means that it reaches the minimum there. If your function is concave down in some region and your extreme point is also there, it means that function reaches its maximum there, okay? The result is like a logical, and also it is the same as we did in the previous one, right? Again, if I ask you, tell me the maximum, you should not tell me minus 1, right? So minus 1, it's the point where, it's the point on the x line, where your function attains its maximum, right? Maximum will be f of minus 1, okay? So the concave up is in the region from minus 1 over 4 until the infinity, right? And concave down in the region from minus infinity until minus 1 over 4, okay? Don't be surprised. So this is kind of like like if your function attains its maximum, then the second derivative should be negative, right? So it's kind of vice versa, right? So if it attains its maximum, the second derivative should be negative. If it attains its minimum, the second derivative should be positive, okay? Do you understand this? Yes? So second derivative do not tell you increasing or decreasing, right? So that is why when it is plus or when it is minus, do not make the mistakes, okay? Good. So the point where the function changes its concavity is called the inflection point. Inflection point here is equal to the x is equal to the minus 1 over 4. The point where the function changes its concavity, okay? So before minus 1 over 4, the function was concave down. Then after, it became concave up, sorry, okay? So if I ask you to sketch the graph of the function, what you would do? What you would do? So you know that in the minus 1 over 4, right? Or let me draw this like this. Before minus 1, the function is increasing, right? And after 1 and until 1 over 2, the function is decreasing, right? At the minus 1, it reaches 6, right? So 6, let's say 6 is here, right? Before this, it's increasing, right? But I also know that before minus 1 over 4, the function is concave down, right? Concave down, like this, right? And after this, the function becomes concave up, right? So it reaches its minimum at the point 1 over 2, and its minimum is equal to the minus 3 over 4, right? Somewhere here. Let's say this is minus 3 over 4. The graph of the function, by some analysis, should be like this, right? It is concave down in this region, right? Then after minus 1 over 4, it becomes concave up, right? Do you see that this is concave up, right? Then it reaches its minimum value at the 1 over 2. Then it increases, okay? You can roughly sketch the graph of the function by just knowing the concavity regions and by just knowing the increasing and decreasing regions, right? So from our analysis, we've got the result there. Until minus 1, the function is increasing, right? From minus 1 until 1 over 2, the function is decreasing. Do you see that it's always decreasing, right? Until 1 over 2. And after 1 over 2, the function is increasing again, right? So from the analysis, I've got the result that from minus infinity until minus 1 over 4, the function is concave down, right? Do you see? It's concave down, always. So if you take any tangent line, it will be always above, right? And after the minus 1 over 4, the function is always concave up, you see? So at the point minus 1 over 4, it changes its concavity from up to the down. From down to up. Okay? So you will probably have this kind of question in exam.